Have you ever wondered what the future of science holds? What about chemistry? What will it look like 100 years from now? We think of chemistry labs with bubbling beakers and colorful reactions, but what if I told you that in the 22nd century, chemistry has gone from macro scale to nanoscale? Absolutely. Let's dive deep into futuristic 22nd century chemistry step by step, as if you're watching a high-end educational documentary, explaining the science, the transformation, the real-world applications, and the comparison with today's world. In the past, humanity discovered elements. Today, we build them. For centuries, the periodic table, a masterpiece of scientific organization, felt like a finished symphony. We marveled at the 118 elements, the building blocks of all matter, from the air we breathe to the stars and the cosmos. But what if we could not only understand these elements, but actually create them? That's the reality in the 22nd century, thanks to atomic engineering. Imagine a world where we are no longer limited by the scarcity of rare earth elements, crucial for our technologies. We can now create them on demand. How, you ask? By manipulating the very heart of matter, the atom. We've all learned about protons, neutrons, and electrons in school. In the 22nd century, we've become masters at manipulating them. Using sophisticated instruments, we can now fine-tune the number of these subatomic particles within an atom's nucleus, essentially transmuting one element into another. Need more gold for electronics? No problem. We can now transform readily available elements like platinum into gold by altering their atomic structure. This isn't alchemy, it's pure science. This ability to build elements from scratch has revolutionized industries. Take, for instance, the medical field. We can now create custom-designed radioactive isotopes for highly targeted cancer treatments, minimizing side effects and maximizing effectiveness. But the implications go beyond. Remember the energy crisis of the 21st century? Atomic engineering has provided a solution by enabling the development of safe and efficient fusion reactors powered by readily available elements like hydrogen. Reactions are no longer guesses in beakers. They are blueprints for molecules, built atom by atom. In the 21st century, 3D printing revolutionized manufacturing, but it was limited to manipulating bulk materials. The 22nd century ushers in a new era: molecular 3D printing. Imagine a world where we can print anything from life-saving drugs to self-repairing materials, atom by atom. Remember the painstaking process of chemical synthesis in the past, full of trial and error, heat, and hazardous materials? Molecular 3D printing has replaced all that. Think of it as a highly sophisticated, miniaturized assembly line for molecules. We feed the printer a digital blueprint of the desired molecule, and it gets to work. Using precisely controlled beams of atoms or small molecules as ink, the printer meticulously assembles the desired molecule, atom by atom, layer by layer. Need a specific drug to target a particular virus? No problem. Input the molecular structure into the printer and voila! The drug is printed, ready to be administered. But it doesn't stop at pharmaceuticals. Imagine printing custom-designed materials with specific properties. Need a super strong but lightweight material for building spaceships? Molecular 3D printing makes it possible. This technology has democratized manufacturing. Remember the days of massive factories and global supply chains? With molecular 3D printers, anyone can become a creator, designing and printing products at home. The implications are staggering. From personalized medicine to sustainable manufacturing, molecular 3D printing is reshaping our world, one atom at a time. Chapter 3. In the past, reactions were slow, hot, and dangerous. Now they're cold, clean, and quantum fast. Remember those chemistry classes where we learned about catalysts, those substances that speed up reactions? In the 22nd century, catalysts have gone quantum, ushering in an era of instant, zero-energy reactions. For centuries, we relied on heat, pressure, or catalysts to overcome the energy barriers inherent in chemical reactions. These methods were often inefficient, energy-intensive, and sometimes dangerous. Quantum catalysts have changed everything. These marvels of nanoscale engineering work by manipulating the quantum properties of atoms and molecules. Imagine a catalyst that can precisely control the energy levels of reacting molecules, guiding them along the reaction pathway with incredible precision. The result? Reactions that once took hours or even days now occur in fractions of a second, at room temperature, and without the need for harsh chemicals or high temperatures. It's like watching a chemistry experiment on fast forward, but without the explosions. This has revolutionized countless industries. Take energy production, for example. Quantum catalysts enable us to extract energy from renewable sources like sunlight with unprecedented efficiency. Imagine solar panels that can convert nearly 100% of sunlight into electricity, thanks to quantum catalysts facilitating the energy conversion process. But it's not just about efficiency. Quantum catalysts also hold the key to solving our environmental challenges. Imagine catalysts that can break down pollutants like plastic into harmless substances instantly, cleaning up our planet at an unprecedented rate. Chapter 4. Molecules no longer just react. They think, learn, and adapt. For centuries, the line between living and non-living matter seemed clear. But in the 22nd century, that line has blurred, thanks to the emergence of living chemistry. Imagine molecules that can remember, learn, and even make decisions, mimicking the behavior of living organisms. This groundbreaking field draws inspiration from nature's most complex creations, our brains. Scientists have designed synthetic molecules that can form networks, much like neurons in our brains, capable of processing information and even exhibiting a rudimentary form of intelligence. Imagine a material that can heal itself like skin. Scientists have created polymers that can detect damage, such as a cut or scratch, and then use their molecular memory to guide the repair process, regenerating the damaged area seamlessly. But the implications go far beyond self-healing materials. Imagine medical implants that can adapt to the patient's body, releasing drugs only when needed, or even regenerating damaged tissues. This fusion of chemistry and biology has opened up a world of possibilities, blurring the line between the living and the non-living and challenging our very understanding of life itself. Chapter 5. The biggest miracle of chemistry? We don't just fight pollution, we transform it. For centuries, pollution has been the bane of our existence, a byproduct of progress that poisoned our planet. But in the 22nd century, we've achieved a paradigm shift. We don't just fight pollution, we transform it into something valuable. Imagine a world where carbon dioxide, the notorious greenhouse gas, is no longer a threat but a resource. Using advanced chemical processes, we can now capture carbon dioxide from the atmosphere and transform it into valuable products like biofuels, plastics, and even building materials. Remember those massive landfills overflowing with plastic waste? They're a thing of the past. We've developed catalysts that can break down plastic into its molecular building blocks, which can then be used to create new plastics, fuels, and other valuable products. This is environmental alchemy at its finest, transforming our waste into valuable resources and closing the loop on pollution. It's a testament to the power of human ingenuity and our ability to use science to solve even the most daunting challenges. From building elements from scratch to creating molecules with memory, the 22nd century has witnessed a revolution in chemistry. It's no longer just about understanding the world around us, it's about creating a better one. Chemistry has become the science of creation. It touches food, medicine, construction, technology, even emotion. It is the language of matter. And in the 22nd century, we finally speak it fluently.